Ladies and gentlemen, we had a request to do the final question on our fourth exam this semester. Good review for the final. Fall 22 T4, part 4. This is the thionyl chloride with alcohol. On your final, titles will be there. I don't think you knew that. Thionyl chloride with alcohols. It's both in our book and in our studies that we did during the period leading up to this exam. Yeah, we did this one. I sent an email saying you must watch this video for this mechanism. Okay, thionyl chloride with alcohols, and that's an I right there. And this one is, well, secondary RX, moderate nu, polar protic solvent, what are you saying? If you have those 3 analysis points, then what's the only conclusion you're making? I got the first one saying, I don't know. I got the second one saying, I don't know. I got the third one saying, SN1. And on the test, it would need a title, but I would just say substitution reaction. Substitution/elimination reactions. Not telling you which one it is though. E1, E2, not telling you. It would be E1 because SN1 is major, E1 is minor. Yes, it's a chapter 9 reaction. Okay, so save yourself a little effort on this test by circling a part that doesn't change for the whole mechanism and call it R. First step, and students didn't do very well on this mechanism, so apparently other people didn't know it was coming. But it's coming on the final, I promise. So what we have is an H bonded to an O, bonded to a carbon with a methyl and an R. And the new group is right here. It's an S with an O minus, Cl, Cl. Don't forget, there's a plus charge on this oxonium. Pyridine's role is to neutralize strong acids. So I'm going to redraw pyridine right here because I don't want arrows crossing. Double, double, double. Grab H. It doesn't like that spot of the screen. Make it a little tighter here. And you have R with an O, bonded to an S, an O minus, with 2 Cl. Okay. So what's next? Any ideas? Yeah, I'll cut to the chase. We're getting near the end. It eliminates one of the Cl minuses. Cl minus is a nucleophile now. Little hint here, you need to get to here. Yeah, that's a hint. That's your SO2. Your pyridinium happened right here. Your pyridinium happened, I wanted yellow. Pyridinium. You don't need to show me these arrows showing when did you make pyridinium. No. How do I get to the end, everybody? The Cl ends up on which carbon? The carbon with the methyl, this carbon. How do you propose that happens? How do you propose this bond between the Cl and this carbon happens? Tell me where your electrons start and where they end in the arrow. I need a bond between Cl and carbon. I am starting with these two things here. How does your arrow start? Say it again. Chlorine what? The 1s orbital of the chlorine? The 2s orbital of the chlorine? The lone pair of the chlorine? Yeah. If I see this on a test, some of you can be witness. When you did this on a test, what did I write on your test? Because you're going to lose something. You're going to lose something for what you just did. Because you couldn't tell me what pair of electrons to start the arrow with. You couldn't. Nobody did. Tell me why you're losing a quarter point. Minus 0.25 right now. Arrows represent the flow of electrons, and you have an arrow that starts where there are no electrons. Okay. Starts at the lone pair, attacks backside the carbon. There's your bond between Cl and carbon. Is there a bond between carbon and oxygen in the final product? What do you propose you do with the bond between carbon and oxygen that's green right now? Break it and go where? I want to hear it like it is. What kind of a bond is it becoming? There is a bond between O and S. Can you say make a new pi bond between O and S? That's what I want to hear. Okay. Any other things? Is there a bond between S and Cl in the final product? Please tell me what to do with the bond between S and Cl. Break it and it goes where? To Cl, because Cl is an excellent leaving group when it has a lone pair and a minus charge. Okay. There we go. We got it. Done. And if this is a stereo center, which it is, based on your knowledge of doing an attack on a stereo center, in another question on the test, if that was an R stereo center, what will it be when you're done? S, because you did a backside attack. All right, this one's not about stereo centers, this version right here, but it could be in the future. Okay, good news. All right. We did an analysis and I wrote SN1. Guys, you have to know what that means because it tells you how to start the mechanism. As soon as I say the word SN1, not a word, it's a symbol, what is the other word that comes to your mind immediately? Because it tells you what you must do first. Carbocation. Step 1, make carbocation. I need one arrow. Where does it start and where does it end? I'm going to do what you said and take points off. She said start at Cl. No, from the bond to Cl, then would electrons go from a less electronegative towards a less electronegative atom? That's what you told me. Don't do that. That is wrong on many levels. Carbon is less electronegative. It will not pull electrons from a Cl. Every time a leaving group leaves, it takes electrons with it, guys. That's not changing. It happened over here. Where did the electrons go? To the Cl. Is this different? The only difference is it's unimolecular instead of bimolecular. It's happening all on its own. And you're making a secondary cation. I don't think I'm going to use my R anymore. In fact, I'm going to stop. And we're going to do the next mechanism on a separate video. Okay, so we're coming back for this one. We're going to have a carbocation and Cl minus. And I'm gonna just grab the portion we need and use that.